meeting as usual. Please be aware of that. Okay. So thanks everybody for joining. Yesterday we were talking about green screen and how to implement green screen. And I left that as an exercise, the faded green screen and the multiple green screens. I'm wondering if anybody started working on that.
I think I got the faded green screen.
And who's that? Sharia, is that you?
Yeah.
Okay.
For me, the faded green screen came preloaded.
Yeah, for me too.
Preloaded?
Yeah,
It came preloaded when you opened up the slideshow. It already came with you.
But it wasn't faded. It wasn't faded. It's not faded. Oh, it's a regular green screen. It's a full implementation of green screen, but it's not faded. So that's the trick. So who has an implementation of the fading algorithm that allows us to see both the original image partially superimposed with the green screen image?
Couldn't you just change the threshold to make it kind of look faded?
Well, if you change the threshold, you change the pixels that get affected by the green screen machinery. So you can have more pixels or less pixels that get replaced, but once they get replaced entirely.
You can
Here's what we can do.
Divide it by a number.
Let me share my screen. Let me go find the appropriate page. That was fancy filters. Lesson 7. Okay, how do I share my screen? Present, entire screen. Good. So you guys see my fancy filters presentation?
Yes.
Excellent. Okay, so faded green screen. So this is the goal, right? Ideally, we see both. If we had bananas and Paris, we would see both the banana and Paris together. Okay, now this particular image that you're seeing shows you, a banana superimposed on the Eiffel Tower, but this is not a green screen implementation in the sense that, as best as I can tell, the two images are just superimposed. Every single pixel of one image is superimposed every single pixel of the other image. We're looking for this effect, but we're looking for this effect to only apply to the background. In other words, we want the teddy bear to, and it's not a teddy bear. Some of you will want to tell me that it's something other than a teddy bear. I acknowledge it's something other than a teddy bear. I just don't know what it is. But anyway, whatever it is, we still want that to be in the foreground and not be affected by the green screen at all. Does that make sense?
Yeah.
Yeah.
Okay, great. So how do you do that? Do I have a volunteer? I had once upon a time an evil but very effective French teacher who would look for her next victim from among the class. She was never very successful at getting us to volunteer, but she always picked one as her volunteer for the day, and that kind of worked.
How's your French?
C'était assez bien.
Hey, pretty good. Not bad. Not bad.
So really, guys, come on. This is a great opportunity to learn by doing.
Iggy said that he had them.
What was that?
Iggy said that he had the answers to both of them.
Iggy.
Well, okay, I know I definitely have the answer to the second one. Looking back, it's not possible. It's possible I have the answer to the first one. I'm not sure. I'm pulling up the slideshow right now.
Why do you do that?
But I can. Do you want me to share my screen?
Go right ahead. But if you have the answer to the second one, you might want to volunteer for the second. If I could have somebody volunteer specifically for the first, that would be better. And if not, we'll let you go. Qui je parle français aussi? Druva, c'est très bien. We will switch to French from now on in this class.
Or at least a French accent when you speak English.
Absolument, yeah, of course. Oui, baguette. That's not how you spell baguette. Come on. Okay. If we don't have any volunteer who was talking earlier, Iggy, is that correct?
Yeah.
Okay, Iggy, go right ahead. Let me unshare my screen, and then you can share yours.
There we go. Okay. Did that work?
Yes, it's working.
Cool. So for the first one, I thought it would be an else loop or add an else loop. So we would do the if it's whatever, then you add it you add the back screen in, and if not, then you take the average of the front and the back and then put that in. Is that sort of what the answer would be?
That's not how I interpreted it, but it's perfectly fine. That does show the idea of merging the two images, which is really what I want to see here.
Okay, so I deleted it, but basically what I had was I would just take the pixel or back pixel, get red, and then I would take pixel, get red, I would divide them by 2, and then I would do the same thing for blue and also green, and then I would use that, and it would sort of like have a faded monkey and then the full rest of everything else.
Okay.
Was that sort of what the answer would have been?
That's kind of like what I had in mind, yeah.
Okay. Should we move on to the other one?
Well, that doesn't quite work, though.
Oh, it
Try
doesn't
it out.
work?
Not
So I
really.
type out the whole thing?
PEMDAS.
What's that?
Oh yeah, parentheses, right? Order
Parentheses?
operations.
Yeah,
Let
definitely.
me just copy and paste this and replace the red with blue.
That's clever.
Thank you, Sanjay. See.
And also a way to get copy paste errors in your code, but that's okay. You'll learn
Yeah,
that
I'm
later.
checking to make sure I did this right.
Yeah.
Okay, here we go.
Yep.
Oh. All right. Do I need another?
What is this? Remind me again. What is this? Is pixel dot is similar to 100, 150, 150, 70? What is that? I forgot.
So,
Yeah.
go ahead.
Oh, I didn't actually know. Yeah.
So let me go back to your screen. So we are trying to identify pixels to replace with some other source of information based on whether they are similar or not to a given color. So the green screen, the canonical green screen would be, we're replacing everything that is green with another color.
All right.
Okay, so we're asking the question, is this pixel similar or not to the one that we want to replace, to the color that we want to replace? So 100, 150, 150 is the color, the RGB color that we want to replace, whatever that is. It's probably the blue-gray, one pixel with the blue-gray.
How did they get that number? 100, 150, 170? Was that given to us?
It's part of the text of the problem.
Oh,
so
okay.
It's already,
so they already gave it to us. Okay.
They already gave it to us.
Cool.
So what you've implemented is you've partially superimposed the teddy bear to the picture of the Earth taken from the moon. Okay, which is fine. Totally fine. It showcases that you can mix two different images by using an average. And you're using a pure arithmetic average. So you're using back pixel plus current pixel divided by 2. Get red, get blue, and so on. But you're basically just adding the 2 images and dividing by 2, which is fine. A slightly fancier approach is to have a mixing factor and determine how much do I want of this image versus how much do I want of the other image. Let me show you what I got.
Cool. I will stop presenting.
Did you do a prompt with the mixing factor?
No, I didn't. I could have, but I just left it not the right file. No, actually, this is it. Yep. Okay. Let me copy and paste this. Let's go to this other fresh copy of my presentation. Okay, so this is the original code that we get from Ms. Taylor. Run that, and we get the plain vanilla green screen. This is the original image. We have the one on top of the original image. We have the teddy bear with a gray-blue background. In the second image, we have the teddy bear that's floating in space between the moon and the Earth. Now, we would like to show, I think the way I've interpreted the question is to show, to sort of mix the original background of the image with the new background of the image. And here's how I've implemented it. So I am selecting the back pixel for the, off the bat by using back.get. Sorry, actually, that was coming from the original code, so nothing new. But what this does is it identifies the pixel in the other image as a first thing. Then we ask the question, is the pixel similar to the color that we want to replace? Fine, it is. Okay. So now what's the color that we want to replace this pixel with? And I'm using this mathematical operation. I'm doing back pixel get red times back percentage plus pixel get red times image percentage. And back percentage I'm defining as 50%. And back percentage I'm defining as 1 minus 50%, which is 50%. So in this case, I should get something very similar to what Iggy got because my back percentage and my image percentage are both 50%. So ultimately it boils down to the same math. Now I'm doing it, the other way around. I'm providing 100% of the image and 50% of the image and 50% of the background in the area where the green screen is being detected. Okay. So as you can see, nothing really happened actually, as you can see. So that's not good.
I think you forgot to print it at the end, maybe.
That could be, but I don't. Actually, you probably are right. Print image. Let's see. There you go. Yeah, so this is the original image. And the second one is the mixture of, or is the image where the green screen is being replaced with a mixture of the green screen itself plus the new image. And so you can still see the image of the Earth taken from the moon, but you can also see a little bit of the hazy background of the original image. Now, with this technique, with this mixing percentage, back percentage, I can say, well, I want more of the new background. So instead of 50, I can say I want 75% of the new background. There you go. It's a whole lot blacker now. And you can still see, at least from my perspective where I am, I can still see a little bit of the hazy blue-gray background of the original image, but not a whole lot of it. On the other hand, I could go down to 25%, and now I can just barely see the Earth behind a thicker cloud of haze.
That's pretty cool, huh?
I have a question.
Please.
What is the use of faded green screen like in movies and stuff? Like, why do people write this code?
So let me give away my age. You guys have seen the original Star Wars episodes. What were they? 4,
Yes.
5, and
Yeah.
6.
Yeah.
You remember in episode, what's that?
A New Hope. You were the New Hope.
I no, I am not Luke Skywalker, unfortunately. But you remember the holograms appearing in the middle of the air, right? In the spaceship where the characters were traveling.
Yeah.
And if you remember that scene, in that scene, you can see Princess Leia recording her message to Obi-Wan Kenobi, but you can also see what's behind her. In other words, there isn't a solid image of Princess Leia and nothing behind her, and that completely obscures whatever's behind her. You can see Princess Leia, but you can still see the background.
That makes sense.
Oh,
Let's see if I can find that. Not image, YouTube. Star Wars New Hope Leia message.
Help me, Obi-Wan Kenobi.
Yeah.
You're my only hope.
Oh, I'm very proud for you.
woohoo.
I love
Very
Star
proud.
Wars.
Audio?
I'm not sure that I can share the audio. There you go. As you can see, that's Leia, but you can still see Obi-Wan Kenobi in the background. You can still see the stairs in the background. Right?
Yeah.
That's kind of what I was referring to. So this is an example of a less than 100% application of the green screen algorithm. So here you can see it very well, right? You can see the bottom of Leia's dress, and you can still see the table behind her. Okay?
Hey, Alex, somebody wants to join the call. Can you just check?
Oh, yeah. Dankeschön. All right. So that's cool. Okay. Now we want a volunteer for the second exercise. And it would be nice if somebody other than Iggy stood up to the bat. To the plate, I guess. No? Iggy, do you want to go?
Sure. Give me a sec.
Avni says silence. Yeah.
Okay. Can you see this?
Yeah.
All right. So this is what I did. I set up a bunch of variables at the top. So this is the B in front of the red means it's going to replace the blue, and the R means it's going to replace the red and the stop sign. And then I did 2 different if loops where it would replace either the blue or the red with either back 1 or back 2. And then this is kind of what I got. It's a little bad, but I guess I could toggle around the numbers more and get it more precise. But that's generally what I got.
Hang on. I lost my window for whatever reason. Okay. Yeah. So show us the structure of your code. So you're saying for every pixel in the image, what are we doing? If the pixel is similar to be red, be green, be blue, and be red, be green, be blue represents the RGB value of, again?
That would be it's supposed to be the value of the sky. So if it's similar to like the color of the sky or whatever,
Okay.
then we'll replace it with back 1, which is Yosemite.
Yosemite. Okay, and so you are identifying the pixel. Let back pixel 1 is equal to back 1.getPixel of x and y, where x and y have been taken from the current pixel. So now you identify the red value of that, the red, green, and blue value of that pixel, and then you set it in the current pixel of the image itself. And then I guess you do the same for the other thing. Are you using an else statement?
No.
Okay. It probably is the same thing, because if a pixel is similar to something blue, it's not going to be similar to something red, right? The second if statement is about something being red. So if it's blue, it's not going to be red. If it's red, it's not going to be blue. But if you wanted to make sure that if it's detected to be part of the sky, it's not also detected to be part of the stop sign, then what you would do is you would use an else if. So after the close bracket or close, curly brace, at the end of the first if, you would add an else, followed
like-
again by an else, by an if. Yeah, just else if. Yeah, execute that, and then you close the curly brace. Yep. Lo and behold, you have the same thing, because in this case, it really doesn't matter. You would be saving a little bit of time by adding the else statement, because you wouldn't be evaluating the question about whether the pixel is red. If you've detected it to be blue, there's no point in asking yourself the question, is it also red? Okay, that's very minor at this point.
Yeah.
Okay, that's super duper cool. I think we're done with coding for today. Sanjay, do you want to step in?
Yeah. Do you want to just kind of like recap everything that you did in like 5 minutes or 10 minutes with them on coding, just to wrap it up? Because I think after this, we're going to start covering some different types of topics.
Yes. So the last few days, we've given a quick introduction to programming. We've presented a few key concepts, and we've presented them in the context of JavaScript. Obviously, this is not a full class in JavaScript. It's not even a full class in programming. But the goal was to give you a taste of what programming is like. So some of the concepts you have seen are variables. Variables are names to which we assign values. You have seen functions. Functions are particular variables that are interpreted as mathematical functions, functions that can take parameters. And when they take parameters, they evaluate to a value. So we've seen how to call a function, the syntax for a function call in JavaScript. Like we've seen, am I screen sharing? I'm not screen sharing, right? Hang on. Let's go back to some of the code that we have here. So the syntax for a function call is, for instance, this. Okay, set to zoom 0.5. Okay, that's the syntax for a function call. So set zoom is a function value, and we are invoking it on the value of 0.5. So parentheses help us call functions. I've also explained the notion of a method. A method is a function that's attached to a particular object. In this case, setZoom is a function that's attached to an image called back. And so when we call the setZoom function, it operates, if it makes any changes, it would make changes to the object that it is attached to. And I've given you the analogy of a method sending a message to an object, and the object reacts to that message. What else have we seen? We have seen for loops, and we have seen one particular variety of for loop, the more interesting one, the more powerful one, the one that we also call the for each loop. That's a fairly novel construct in programming. They have been around, in modern programming languages only for a relatively short time, maybe about 10 years, maybe less. And so we read them as for every thing in a collection of things. Okay, for every pixel in the image, do this stuff. Okay, and so within this open curly brace, close curly brace, this is called a block. Within this block, we have access to one pixel. And this block will be executed however many times is necessary to run it for every pixel. That's a very powerful type of iteration, okay, or of loop. And then we've also seen conditional statements. Conditional statements are the if statement and the if-else statement. If has two parts, if-else has three parts. The first part of both if and if-else is the condition. This is a condition. And a condition is a value, or it's an expression that evaluates to a Boolean value. Boolean value is something that is either true or false. And so the if statement executes its body when the condition is true. And it does not execute its body when the condition is false. The if-else statement executes the if true part when the condition is true, and executes the else part when the condition is false. So by combining loops and if statements, we can have a very powerful programming language that allows us to implement all sorts of things. These are the key concepts. Okay, we've gone into some other detail about the let variables versus the sort of old school JavaScript variables. None of that is terribly important for the purposes of this class. The key concepts here are, I guess, variables, for loops, and if loops, and methods. Good so far?
Yeah.
Makes sense.
Okay. I think we're good to move on.
Okay, guys, just one more thing. I was thinking, those of you, I know it's been a little difficult to go through these exercises and kind of keep up with some of the folks. That's just natural. But I really recommend that you guys go over the notes again, go over the links in the document, and try to make sense of it. Try to work through the exercises, because I think you could learn a lot. So anyway, all right. Thanks, Alex, so much. If you can stop sharing now, I will start talking.
There you go.
Okay. Okay. So switching gears to a different topic. So today's topic is spreadsheets and data. And we're going to talk about what these things are. If you guys aren't familiar with what spreadsheets are, we'll talk about that. And we'll talk about stuff that computers are really good at doing, right? As we went through the last few days, we've seen that computers can do exactly what we tell them to do. But you have to be the person who is defining the algorithms, or defining the thinking, right? And that's the code. So some of the stuff that we've seen over the last few days, even that you guys have been doing, has really been your ideas. It's been, how do I actually make this happen, right? How do I understand how to load the data into variables? How do I then go extract data from those variables, from those images? And then how do I define and develop the algorithms, the code, to go manipulate or change that data into something that we want, like the green screen, which used pretty much all the concepts that you've learned so far. Used variables, loading files, functions, arguments, parameters, for loops, if statements. I mean, it was all there. And that's really amazing. But that was just an instance of one type of data. Images are fun because we can see them. There's other types of data as well, right? As you can imagine, all of you are enrolled in school, for example. Or Alex and I, we work in companies, and so there's information which is stored about us. So there's tons of data available which people want to look through, right? Imagine you go to the doctor, they want to know that, hey, does this person have medical insurance? What's their copay? Like things like that, right? And so the point is, computers are storing tons of data about all kinds of different topics and subjects, and the format of that data could be, imagine the database of U.S. citizens as a great example. When the government is issuing a passport or a driver's license, there's data about your photograph, there's data about your date of birth, your address, There's the security data that the security agent will scan under the light so they can tell whether it's an authentic document or not. And so much data is different types of data. But today, what we're going to focus on is how do we look at a large amount of text-based data? How is that stored in this specific or special type of container or document, which is called a spreadsheet? So the first thing I want to do is I want to show you a spreadsheet, right? So hopefully you guys can see this. Can you see this?
Yeah, we can see it.
Yeah.
Okay, excellent. So this is an interesting spreadsheet, right? This is a spreadsheet of, I don't know when this was updated, but pretty much I'm going to send you guys this link in the chat real quick. And I'm going to show you some things that you can do. So this is a list. It's a long list. Okay, I'm going to keep scrolling down this thing. You can see it's a ton of information. It is mostly text. Some of it is numerical. Some of it is dates, right? And what you're seeing here, really interesting, is that every row or every line of this data represents information about one particular character or person, right? So this is similar to your U.S. government database or your medical records we talked about, or your school enrollment system, which says, hey, Nathan's a student at Bret Hart, and this is his address, and this is his date of birth, and et cetera, right? So this sort of data that you're seeing here, which is stored in rows, right, which is left to right data, and columns where you kind of see some interesting kind of pillars over here. We'll talk about each of those. This sort of data is typically called a table. And when you have a table that's stored in a document like this sort of document is called a spreadsheet. Okay. Now, as you can imagine, you can have, hundreds, tens, millions, billions of pieces of data like this. Let's look a little bit at what is a row and what is a column. You'll notice that every column is a particular type of data. So whoever has put together this set of data has one column which is comprised of names of people. In this case, Marvel Comics superheroes, right? Or Marvel comic characters. Sorry, what?
Who made this whole spreadsheet?
It's a great question. I don't know the answer, but I think it came from Marvel Comics at some point, or somebody compiled this and put it together. It's a really good question, actually, because who makes data, right? The answer is we make data, right? It's somebody who has a purpose for this data. They start putting together a list. What's initially a list, it's like, hey, put a list of my friends together, right? If let's say your mom or dad says, hey, whose birthday's coming up, or are you going to have a birthday party? Put together a list. So you put together a list of your friends, maybe it's like 10 people or 15 people or 20 people, right? And then your mom's like, well, who's this Sanjay guy? Right? Why are you inviting him to your birthday? And you'd be like, oh, he's this guy. Like, I made friends with him recently. And your mom's going to be like, okay, well, where does he live? Where did you meet him, right? So when you have very simple data, there's usually an understanding that we know what this data is, right? It's my list of friends. And it's pretty obvious that it's my list of friends. But sometimes when you throw some guy like Sanjay in there, it's not really obvious who this guy is. And so your mom will be like, where'd you meet him? Say, oh, he's the guy. He was one of the guys teaching the CS class. Oh, okay, cool. So he's going to join you by video conference then. That's okay. I don't need cake for him, right? So your mom's going to kind of like look at that, and we're going to build out a more detailed list of characteristics or items that describe the data. Okay. And each type of item that describes the data, so this could be something very simple like name, date of birth, street address, which school you go to. That may be all there is to this, right? It could be like a student ID number if it were in a school, parents' names, I don't know, nationality. But in the case of this Marvel superhero character universe, this list of data, you can see it's like thousands. I think it may be 11, 12,000 lines, which is quite impressive considering that this is just the Marvel comic universe. They have defined a set of characteristics by which we can identify each of these people. For example, let's look at Spider-Man, right? So Spider-Man is the superhero or the character. The ID is, hey, this Spider-Man has a secret identity, right? When Spider-Man does have a secret identity, then you notice that this name in brackets actually is different from the name that's outside the brackets. So in other words, describing that the thing in brackets is the secret identity. Okay. Is he a good character or a bad character? He's a good character. He's part of the good characters. What is his eye color? Hair color? Is this person male or female? GSM, I guess this is kind of an interesting one. I don't know why they're putting these things down. I'm not modifying this data. Is the person still alive or dead? I guess it depends on which Spider-Man movie you watched. How many times has this person appeared in a comic or in a movie or something like that? When was the first time they appeared? In what year? Right? So this is kind of, ignore the stuff to the right over here for now, okay? So this is interesting in that it's a set of data. It's a big set of data. And maybe there's things about this data that we want to know, right? So coming back to our school example, maybe the date is, I don't know, June of 2020. And you guys are in 8th grade or 9th grade or 10th grade or 11th grade. And the school's trying to decide, hey, who gets promoted to the next grade? Okay. So they need to go through thousands of so they need to, okay, Google, stop. So they need to go through their school database or their school spreadsheet like this, and they need to identify from that school spreadsheet who has good enough grades to go to the next year, to be promoted to the next year. So that's one type of question that we might ask about data like this. And the answer to that question actually is kind of interesting. It's, listen to me very carefully. If they have not failed in a single class, right? If they have passed every single class, then promote them. Else, do not promote them. Sound familiar? Right? This is just like code. It's like saying, hey, if certain things about this data are true, then do something. Otherwise, don't do it, right? So the point which I'm trying to make here is that there's many different ways to store data. There's a way to store a ton of data like this. One way of storing a ton of data is called a spreadsheet. There are ways of storing all other types of data, but we won't go through that in this class. What we're going to go through today is when you have a ton of data like this, and you want to try to seek some meaning, or you want to try to, to add, to get some information about this data, right? Whether maybe you have a question which is, hey, how many of these people have secret identities? And there's 12,000 people here. There's one way to do it. You could go through every single line and you could say, does he have a secret identity? Does he have a secret identity? Does he have a secret? And you could do that. It would take you forever. But remember, when you have a ton of data and you need speed, that's when computers are really good. If you can tell them exactly what you're trying to do, right? What you're looking for. You could ask a question which says, how many of these people have appeared more than 500 times in a Marvel comic or movie? So in other words, we wanted to give us this list of people that's above this line, because here's the 500 cutoff, right? It could be, how many of these people have died, right? Deceased characters. Now you can go through all of this and you're like, am I going to count? What could happen if I went to count this manually? The first thing that could happen is I could miss one, right? And that would be a mistake, because when things are really, really close together like this, it's just really hard to go count one by one.
It would take forever.
It would take forever. That's a really important thing, right? And this kind of stuff is not worth taking forever for. I mean, imagine if you went to check in for a flight at the airport and they scanned your ID and they said, please wait for an hour while it tells me whether this was valid or not, right? That would be horrible. So the interesting thing about spreadsheets is you can store all kinds of data. Typically, these things are stored in rows. A row is essentially one piece of the data which identifies various different characteristics of the same piece of data. So in this case, what are the things that are unique to Spider-Man? Spider-Man has a secret identity. Spider-Man is a good character. He has hazel eyes, brown hair, so on and so forth. And there's columns in the data which typically identify the same type of attribute or the same type of information for every piece of data in the data set, right? So for example, this column E will only tell you about hair.
I have
Will
a
only tell you.
question.
Sure.
What is the M, L, and N columns for?
Yeah, so I said please ignore this for now. I'll
Okay.
come to it. I'll come to it in a bit. Okay, ignore this for now. I don't know why they were there, but that's okay. Actually, we can just delete them. Okay, that way we don't confuse anyone. Okay, so now I'm going to switch back to the slides. And over the past few weeks, we've been using JavaScript to learn about code, right? That was great because we learned concepts. We learned how to manipulate data, how to load data, how to mess with it, how to change it. We're going to use the same concepts today, but instead of using those concepts in JavaScript, we're going to use those concepts in spreadsheets, which are tons of data, right? And it's a tool, and we're going to use this tool called Google Sheets to do this. If you guys go to sheets.google.com in a browser, you'll be able to pull up Google Sheets. You can start or create a new spreadsheet of your own. You can define your own columns, your own rows. You could even use this to, decide who's coming to your next birthday party. In fact, I highly recommend it. Send your parents a spreadsheet. Go ahead.
Sanjay, it might be worthwhile showing them how to make a copy of the data
Yeah,
from CS101 class for themselves.
That's a good one. Thank you. So the first thing we're going to do is I sent you guys a link to this drive. Let me do it again in case it has gotten lost in the past. Hey, Dhruva, I tried TI Sheets, but it really didn't work very well. Yeah, we'll add it to the doc.
Yeah, I'm doing that now.
Okay, thank you. Okay, so let's just do this. You go to the drive, you click on Marvel Comics. That will pull up this spreadsheet, okay? What you'll notice in here, it says view only, okay? Please don't click request edit access because it will send it'll send something to Stanford. The poor person will go crazy. Instead, what we're going to do is we're going to go File up here. We're going to make a copy and then call it whatever you want. What I called mine was CS101 _ Marvel Comics. So I did this to mine. You guys can do the same thing. Something like this. And then hit OK. What that will do is it'll create another copy, which is called CS101 Marvel Comics. So now this is your own private copy of that same file, which contains all that information. And now that we have it, we're free to do whatever we want inside that file. And then once we're done, we can even share it with somebody else if we want, which you don't need to do today, obviously. But if you do make that list of invitees to your birthday party, then please share it with your parents by clicking the share button. But we'll do that later. Okay, so everyone good? Thanks, Alex, for that. Everyone got their spreadsheets up and loaded. We're going to start looking through this data real quick. Okay. So the next thing we're going to do is we're going to talk about using Google Sheets. Yes, there's the drive. So, we sent you the link to the drive. To edit files, you can make a copy through the file drop down in the top menu. We talked about that. The next thing we're going to do, I talked about a little bit of this already, used to store text information, links. It links information together in rows and columns. So obviously, If you want to find out, whether Matthew Murdoch has, what is Matthew Murdoch's hair color? This is very similar to going down to Matthew Murdoch, scrolling over to the hair color thing and saying, oh, Matthew Murdoch has red hair. You could do this by writing code, right? Which said if name equals, so it would be something like, first of all, open the spreadsheet, right? So there would be like we had a simple image, you could have a simple table or simple simple table or simple spreadsheet type function. I don't know if that exists in JavaScript, but you can check. You could then go have a variable called the table, right? Or Marvel comic characters, which is that. We could go, get row or get cell or get, this is called a cell. An individual block of data in a spreadsheet is called a cell. So we could go get cell, name 17, comma hair, right? Something like that, which would get us to this, right? We could do that. And then we could write code to do all of this stuff. But imagine writing code, a lot of code every single time to do this. So instead, what folks like Microsoft have done with a product like Excel, or folks like Google have done with a product like Google Sheets, is give us a tool called a spreadsheet tool, which allows us to write similar concepts, but do it in a way that makes more sense for manipulating data, rather than going through and writing a lot of code to process all of this stuff. Because clearly writing code, as you guys found out, it's a real privilege, right? I mean, you have to know a lot of math, you have to know how to think about it, you have to think very logically. That's probably too much work. And yet maybe 40, 50 years ago, that's all people could do before they had these types of tools. So the next thing we're going to do is we talked about rows combining to give you multiple pieces of information about one object, columns giving you the same piece of information for every object. But I mean, this is honestly just a suggestion, right? There's nothing which says that you couldn't have your columns here, and your rows here. I mean, you could have done it that way. It just would be kind of weird to read, depending on how you're trying to look at it. But you could do it that way. It's just generally we store data in this way. Okay. Now, variables in spreadsheets. What is this? This is interesting. So each cell, which is the intersection of a row and a column, is a piece of data. Sorry, this is a different spreadsheet, one about chocolates. Each one is a piece of data, but actually, each one can also be a variable, right? Because a variable is a box that holds data. So we'll explain that in a second. Just hang with us for a few seconds, okay? There's different ways you can format this data. So I want to show you, this is interesting. So you look within a cell, and you see that within the cell, every piece of text is shoved up against the left side of the cell, right? It's kind of jammed towards the left side of the cell. That is something called left justified text. It means you've moved it to the left side. I could easily put it in the center. I could put it on the right, right? I could do anything with this, really. But generally with text, we do it on the left-hand side. You can see here that this word characters kind of spills over because this column isn't wide enough. Hey, guess what? I can make it wider if I want, right? So there's lots of things I can do with spreadsheets to help my data to be formatted better, to be better seen, right? Very similar to code. But I can see here that, okay, this is a little hard to see. If I double click the edge of this, it'll go to exactly the width it needs to be for the widest character, right? So there's a lot of little things I can do with spreadsheets where I can try to better format my data. If I want to make it obvious that this is the headings, I can select this entire row of data, right, by simply clicking here, which selects all of this, and then I can make it bold by hitting this B up here. So there's lots of little useful things that we can do inside of spreadsheets to help us better format, better look at our data, and understand it better. Okay, but before we talked about how do you? Oh, here's the data sets. You can look at this later. Before we talked about, hey, I want to know something about this data. I want to extract some meaning from it so I can understand it better. And so what I'm going to teach you today is how do we actually go through this? How do we learn some basic spreadsheet techniques which help us to extract meaning and information from this and answer some questions about it, okay? So remember, in JavaScript, you had a function name, you had some data that went into the function, you had image.getPixel, you had various ways of manipulating data. That's great, right? Now, here's an interesting question from here. Like, how many appearances of comic book characters have there been in total? That's some question that someone is asking. How many appearances of comic book characters have there been in total? First of all, let's understand the question, okay? So let's go back here and say, how many appearances? What are they talking about? So appearances. Oh, there's something called appearances over here, okay? And they're asking, if you look at this, Spider-Man has had 4,043 appearances. Okay, so Spider-Man alone has appeared 4,043 times in Marvel comics or Marvel movies or whatever at the time when this data was published. Obviously, since then, somebody may have made more Spider-Man comics. So the question they want to know is, hey, what is the total number of appearances across all this data, right? For every single character. So if I asked you a simple question and said, how many times have Spider-Man and Captain America appeared in all of their comics? You could simply take these two numbers and add them together, right? And so what we could do is, this is kind of interesting, right? So we're going to say Spider-Man plus Captain America appeared, okay? And then again, ignore all this stuff on the right hand side for now. Spider-Man and Captain America appeared. And remember, what I want to do is I want to add this number to this number, okay? So what I'm going to do is I'm going to say equal, because I'm going to try and add those two numbers to this number. See, I'm going to select it plus this number, okay? And then I'm going to enter. So let's look at what happened. If I click on this cell over here now, I get the total of these two numbers. By the way, a little trick, that same number has showed up down here as well, right? But what I've done here is I've added these two numbers together by doing saying that this cell, or the result I want here, or this variable result that I want in M3, right? Column M, row 3 is equal to this plus this, okay? And that gives me 7403. So together, we're going to say that Captain America and Spider-Man appeared 7,403 times in Marvel Comics. Another question could be, given that this is the 7th class, how many times have Alex and I appeared together across all of these classes? And the answer is obviously 14, because 7 times for him, 7 times for me, unless one of us didn't show up. And so to do that, you just have to know that information. Maybe you have a table saying how many times did Alex teach, how many times did Sanjay teach. Now that's an interesting question, because I do believe Alex has taught more classes than I have, and so his column for number of classes taught maybe like 4 or 5, and mine maybe 3 or 2, or however many I did before. But this wasn't the question, right? We could ask a different question. We could say, hey, how many times did Spider-Man and Wolverine appear? So now I'm going to go Spider-Man plus Wolverine, right? And again, this is just a label or just a text I'm throwing there, right? I don't have to have that really. But since I'm talking about it, I'm choosing to leave it there for you guys to understand what's going on. And what I have to do is that I have to go here and say, okay, Spider-Man appeared 4,043 times, and Wolverine appeared 3,061 times. Now the total of that would be I2 plus I2 plus I4, which gives me 7104. But that wasn't the question, right? The question that they were asking us is, how many appearances of comic book characters have there been in total? Which means what they want us to do is to add the contents of this entire column, right?
I can't hear anyone.
I can. I can.
I can't.
I think we all can.
Okay.
Oh, maybe
So I'm going to
seven.
keep going
I can
until
hear.
you fix it. I know everyone can hear me. Otherwise, I wouldn't see this little thing up here moving. And also Alex would have said something. So if you could get someone to help you with your computer, will be that'll be great. So
Maybe
okay.
try.
Left.
Okay. Here is another thing. Okay. So let's just talk about. I'm just going to finish this up, and then we'll take a quick break, and then we'll come back. Okay. So the first thing is to understand the question. They want to know how many appearances of comic book characters have there been total. Okay. So if I wanted to solve that, remember, to just get 2 or 3 of these things, I had to do an equals this plus that, right? So I could start writing some code in Excel that looks like this. Anyone see what I'm doing? Oh
Yep.
my God. Am I going to do this 12,000 times?
Use a loop.
Yeah, so that's right. What I really want to do is use a loop, right? So now you guys are seeing where when I have a ton of data, like a ton of pixels, but now I have a ton of whatever, I want to use a loop. Okay. But if I were to use a loop, I would have to be a pretty serious programmer. I'd have to know how to define variables. I'd have to have JavaScript or C++ or some other program to enter my code. I'd have to compile my code, or at least use an interpreted language like JavaScript where at least somebody gave me a run button. And then, as we found out with the pixel exercise, that stuff's slow, man. It's really slow, right? So I want to do something a lot faster. And I also, given that I'm trying to represent the data in a spreadsheet, it would be nice if someone made this a little easier for me, okay? So what you could do instead is learn something new, which is, how do I do loops, or how do I do helpful, useful data manipulation in a specialized tool for handling it? And that specialized tool in this case is called Google Sheets, but you could also do this in Microsoft Excel if you guys have Windows. And they're very similar in many ways, but maybe each of these spreadsheet tools has some slightly different ways of doing things. So we're gonna try and do that. Okay, so I'm gonna go back here and say, how do we do this? We could go write this really complicated equation. If we wrote this really complicated equation, and we copied each and every single cell, we'd do it 12,000 times. We'd be here until tomorrow morning at least, and we'd probably still get it wrong because we'd miss a cell or 2 or 3 or 4 or 50, and we'd just go out of our minds. Okay, so instead we're going to learn some new tools on how to do this better. Okay, someone said it's just like a for loop. That's true, but I don't want to really write a for loop if I can help it. I want to learn now a higher level of interacting with the data using functions, which I'm familiar with, but these are now specialized functions which are inside a tool like the spreadsheet, right? Ignore this for now. Let's go here and let's take a look at some useful functions, okay? There's a bunch of things here. I'm just going to flash it up here for about 10 seconds, and then I'm going to switch back to our spreadsheet so we can finish our problem. Sound good? Okay. Now, what did I want to do? I wanted to total everything that is in this column, everything, okay? So what if I did something like this? What if I had a function called sum, which is add, okay? Everything between here and the end, okay? Now, I can go and say, let me do this again. Sorry, I'll do this slowly. Equals sum, open a bracket, because I'm going to tell it what to add, right? I can go here, click on the cell I want, okay? And then if I hold the shift button down, I can start playing with the number of cells I wanted to add, okay? Now, the problem with this is, oh man, again, this goes forever, and I might keep scrolling forever and forever and forever. And remember, there's 12,000 of these things. Oh my goodness, how many times am I going to scroll this stuff, right? Well, even if I did that, and look, by the way, look at this here, okay? This thing over here is going to move as I select more and more of these. Can you see this thing moving very slowly? Look at that. Look at this thing moving very slowly, okay? By the way, this is telling you how far more you have left to go, okay? Because right there you're at item number 1059, and there's this many left to go. This is really not very helpful either. So instead, what they've done is they've actually given us a simpler way to do this, okay? So we're going to go equals sum, open this. We're just going to select the whole column by clicking on the top. And it says I as far as I goes. You see that? This is very similar to the for loops we learned. Except in the for loops, we said for every pixel from every image. Here, I'm saying, hey, sum I as far as I goes, close this, and then boom, you're done. Does that make sense?
Yep. Yes.
Okay. So you can see just a quick introduction. Let's take a 5-minute break and then come back. Quick introduction, spreadsheets, tons of data. Maybe we have questions about this data. Maybe we want to interpret it. Maybe we want to look at this data. And to do this, there's specialized tools. This one happens to be Google Sheets, which is kind of fun. You don't have to install anything, just load it up in a browser. And now that we know for loops and we know ifs and we know ands and ors and nots and all these things we learned with Boolean logic that Alex taught us about the other day, we're going to now look at a specialized set of functions in a specialized tool to go manipulate data. Pretty fun stuff. So with that, let's take a 5-minute break and we will come back and we will look at some more examples of data extraction, and then I'll start explaining this stuff on the right side and what it really means. Okay? A 5-minute break. Alex, I'll be back.
Okay.
I have the last of my pizza dough. I made 6 of them the other day, so we're gonna have the last 2 tonight. You're muted.
Ouch. Okay. Congratulations.
Sure. No one's talking yet. Okay, cool. We're back. Let's go. Let me get my video on again. Okay, so with that, you guys saw how we could use this special function called sum. Oops, sorry. Equals sum. When I open a bracket, when I write sum, it tells me, hey, sum of a series of numbers and or cells. So I could use sum actually on an individual cell too. I could go sum I2, comma, do this, right? And I could separate the cells that I want to sum by commas, or I could give it a range to operate on. And remember, I could just say, I just only want these, or if I want to select the entire thing, I just click up here and it says, just keep going for all the i's. Just keep going for everything in I. Okay? So that's cool. Tells me the total number of appearances for all this data. Didn't have to worry about, scrolling down all the way to the end. Indeed, I don't even care how many rows of data they are. Stuff like this is really helpful if you have a data set that's going to keep evolving over time, right? Imagine someone joins a school district, or people graduating from college, or more people being born and getting social security numbers, right? These are data sets that keep increasing. And the last thing you want is for someone to set some sort of a limit on how big these things can be. By the way, programmers have made mistakes like that, where they've kind of set the maximum size of something to be X, thinking that, oh, you know what, surely it's never going to get bigger than that. So back in the 60s, when people started building computers, they said, oh, it's going to be 50 years before we get to the year 2000. And so everyone amazingly decided that the maximum number that there would be in a computer would be December 31st, 1999. And so then the question was, what happens when it rolls over to 2000? And would the whole world go crazy? Obviously, it has not, right? Computers are still alive and well. Everything's okay. But this was a huge project that happened in 1999, 2000, which said, how do we make sure that we can have a set of dates that could go on beyond December 31st, 1999? And indeed, as data sets got larger and larger, especially with the proliferation of the internet, and we'll cover even the internet and how Wi-Fi and other things kind of work later in the class. How do you have these large sets of data, and how do you extract information from them? Okay. So the first thing we learned about this is it's possible to have specialized, functions like sum, which helps us do some things with this data, right? We can go add a bunch of stuff together. We could ask another question, which we could be all kinds of questions. You notice the number 1962 here appears in several places, right? We could ask a question which says, hey, who are all the Marvel characters who appeared for the first time in 1962? It's a reasonable question, right? You could ask other questions. Hey, tell me all the Marvel characters that had blue eyes. Reasonable question. Tell me all the Marvel characters that died. Reasonable question. Tell me how many good characters there are, right? Tell me how many good characters there are with blue eyes. There are all these interesting questions that we can start to ask about this data. So let's look at that. I want you guys to go to a browser window now. And as we're working on these problems, I want you to look at some of these functions. So if you type in the name of these functions, like count unique or unique is a good one to look at. Let's start with unique. And type in unique, and then type in Google Sheets at the end. And let's see what comes up, okay? So I'm going to go to a browser. I'm going to go to unique Google Sheets. Hit enter. Okay. How to use the Google Sheets unique function. So let's look at this and see. Oh, well, that's probably not the right one. I prefer to go to our support document. So it says unique returns the unique rows in the provided source range, discarding duplicates. Okay, what in the world does this mean? Let's think about it. So tell me what are the unique pieces of data in this range? And let's look at a real example. Okay, tell me in this set of data of 1, 2, 3, 4, 5, 6, how many unique numbers are there? And the answers would come back would be like, well, there are 6 unique numbers, and they happen to be 1, 2, 3, 4, 5, and 6. If I change this data and I made it 1, 1, 2, 2, 3, 4, 5, 6, 7, right? 1, 1, 2, 2, 3, 4, 5, 6, 7. What I did was I just added 3 new numbers to this data set. 1, 1, 2, 2, right? So 2 instances of 1, 2 instances of 2, 3, 4, 5, 6 as we have. And then I add the number 7. And I ask you, what are the unique numbers in this data set? The answer would be 1, 2, 3, 4, 5, 6, 7, not 1, 1, 2, 2, 3, 4, 5, 6, 7, right? Because even though the number 1 is duplicated, it is only a unique type of data. I mean, it's only, let me put this differently. The number 1 is a unique piece of data, no matter how many times it's duplicated, right? So for example, in this data set now, I could look at this and I could go, I look at this column, identity, and I see that there's a bunch of things in this ID column. One of them says secret identity, one says public identity, one says no dual identity, one says secret, public, right? I mean, how many of these things are there? I don't even know, right? It's like saying, if somebody says, imagine you're working in an airport and you check people's passports as they come in, and you start noticing that people have American passports, Italian passports, Indian passports, Chinese passports. You start noticing this, and at some point you wonder, how many passports are there? And if somebody give you a list of countries like this, you could go through and count every single one of them. Another way to do it is just say, how many unique countries are there, right? So let's use this column L just for fun, or let's go and insert another column here. You can see you can do this kind of stuff to give us some more space to work. Okay, so I'm going to use this column M. And what I'm going to say is equals unique, right? How many unique rows do I have in this particular column? Again, remember, I can just click on top here and say, for the entire column set of B, please tell me how many unique pieces of data do I have in here, right? In other words, how many types of IDs? I'm going to close this bracket. I'm going to enter. And I'm going to find that there's only 4. Okay, there's only 4. Now, what I want to show you here, and the reason why this unique function is so interesting and useful, is because known to authorities identity is not something that we actually see here when we look at this data visually, right? Like I'm scrolling down, look at how much I'm scrolling down. And so if we did this manually, if we did this through visual inspection, we'd probably make a mistake, right? We'd look at this data and we'd go like, yeah, there's 3 types. There's secret, public, and no dual identity. Boom. And then we'd miss all the poor superheroes who have authorities that are known to, have identities that are known to the authorities, right? Known to the cops, or known to, the Avengers, or to, whatever those Nick Fury type people are, whose names I cannot remember. So the nice thing about unique, the function unique, is it allows you to go extract how many individual types of values are there in a particular data set. Okay. Now, for example, we could do the same thing. We could go equals unique. We could go and say, how many types of characters are there? Because here you have good, neutral, and if I scroll down, I suddenly see bad, right? Is it possible that there's a 3rd type? I don't know. Let's click on this and let's find out. And oh, it turns out there's only 3. Okay. So in this case, if we were inspecting this column of data, we would probably say there's 3 types of characters, and we, in this case, be right? Let's go back here and delete this again. And by the way, I encourage you guys to try this in your own spreadsheets. Again, if you want to add a column just to scratch, you click on top here, right-click that column, right? And then, sorry, I'm in this function. Right-click here, and then you can insert a column or insert a row. If you make a mistake and you insert something you don't like, just hit Control Z if it's a Windows computer, or Command Z if it's a Macintosh, which will undo what you last did. There's also another way to undo by going in here to the top and doing Edit and Undo, okay? So the next thing I want to know is, hey, how many types of eyes are there? Unique, the eye. And I think you're getting the hang of this now, that I can use the unique function to go through a ton of data and extract what are the unique items or elements or values in that set of data. Okay, so that's kind of cool. You guys should try this in your own spreadsheets. Try this for about 10 seconds, and then I'm going to come back and we're going to work on some real problems and talk about stuff for about 10-15 minutes, and then I'm going to give you guys 2 or 3 things to try by yourself, okay, which you can come back to tomorrow. So spend about 15-20 seconds trying unique on a bunch of columns. If you go equals unique, open bracket, are they male or female, or is there some other thing? Oh, it turns out that they have 4 types of genders that they are specifying, in keeping with our understanding of how society is evolving and how we are beginning to understand other people, right? Then there is I don't know, how many states of aliveness are there? Unique. And then go here, and so fortunately there's only living and deceased. I have to make a virus joke in this day and age where viruses are neither living nor dead, but look that up on your own time. Very fun. Yeah, so that's essentially how many unique years are there. We could do that, right? Okay, so having you guys now having made a copy of your spreadsheets for yourselves, you know how to add columns so we can create some scratch space for us to work with. We're going to now go through some interesting questions. An interesting thing when you look at data, we're kind of following a theme here. We're following a theme of, hey, if you practice a lot, you start to see that you get better at math, right? If you practice a lot of math, having good skills of logical thinking and practice are what lead you to be a better programmer, because you start thinking logically in a way that allows you to think about, oh, what are the different steps or procedures that I need to tell this computer so it does what I want it to do, right? And so when you look at data, we're going to learn, and there's many different types of functions that can be used in Google Sheets. If you go back to this browser window which you guys had open, they're showing you some functions that are similar to unique. I mean, they do similar things, but not exactly the same thing. For example, you may want to sort some data in ascending order, descending order. There's stuff like that. But if you want to go and look at a comprehensive list of all the functions that are in Sheets, you can do that too, right? You can even go up here. You can say, hey, I'm looking for something that gives me unique values. I'm looking for something that lets me add stuff. So you can go filter down and see what possible functions might exist for your particular application. But remember that you're still the brains, because you're trying to answer the question by using the right functions and manipulating the data in the way that you want. Okay, so one thing that we do when we look at this, and these are just some examples, there could be any number of ways in which you do this, is we're going to use the unique function in many cases to find some categories. Once we have the categories, we're going to say, I want to extract some data. I want you to tell me all the characters who have brown hair. So in other words, from a code perspective, what we're saying is, if the character has a brown hair, right? For each of these characters, go through every single one of them and ultimately tell me for each character's hair type, if that hair type is brown, I want you to tell me what that list is. Okay. And so this is the type of stuff we're going to do in the next few minutes before I let you guys go, and you can work on some of these things tonight or tomorrow by yourselves. Okay. So first question is, which ID has the most number of appearances? Interesting. So let's first make sure we understand the question. Which ID has the most number of appearances? So we're going to go here, we're going to find ID, and we're going to say, okay, how many secret identity people are there? How many public identity people are there? How many dual identity people are there? And remember, there was a fourth one, which was known to authorities or something like that, right? So before we can answer the question, how many, which ID appears the most times, right? Or how many people in this list have a certain ID, and which is the largest number of people? It's the largest group of people, right? Is the question they're asking. The first thing which probably makes sense is for us to understand how many IDs there are. So we'll use a unique function to go in to this column, we'll pick it, we'll go, oh, okay, well, looks like, sorry, I'm going to do this again over here just so we have some space, okay? It'll become a bit messy otherwise. Equals unique, B, boom, boom. So I find that there's 4 types of identities. Okay. Now I'm going to ask myself a question, which is going to be number of, characters or ID. Okay, how many of these characters are secret identity? How many of them are public identity? How many of them are no dual identity? And how many of them are known to authorities identity? This is the question we want to ask. So we're going to say equals, and we're going to use a new type of function now. Function actually is called count ifs. Count ifs. Okay, what is this count ifs thing? This count ifs thing is a bunch of functions. It's one of a bunch of functions called the ifs functions, right? This is the sum ifs, count ifs, max if, min ifs, blah, blah, blah. We can go later on, figure out what each of those do. But the count ifs function is interesting. What it says is, hey, I'm going to specify a range of data. I'm going to tell you, look through this data and count it, right? Count it if the data does something, right? If the data meets a certain condition. So if the data meets a certain condition, count it. So in this case, what they're saying is there's a certain data set that they're looking at. They're saying, hey, count the data if it's greater than 20 and less than 30. Sorry, if this range is greater than 20 and that range is less than 30. In our problem, we're going to say, hey, count I lost my train of thought. Oh yeah. So count the number of instances of this thing, right? Only if, and look over here. Look over here to understand what I'm doing, okay? Equals count ifs. I'm going to count the number of instances in this column B, right? This thing appears. Secret identity appears. Okay? Count in this column B how many times that thing appears. Hit enter and I get 6,275. Okay, cool. So pretty fast, it went through this entire set of data, and it said how many of these are secret identity. Okay. Now here's a really cool thing I'm going to show you. I'm going to go down here. I'm going to do the same thing for public identity. Count ifs. Again, I'm going to go here, click this. Again, I'm going to go comma. But now for the criteria, I'm going to set public identity, right? And then I'm going to close this bracket, and it's going to tell me there's 4,528 people or characters which have a public identity. Okay, cool. Now, if I want to do these two, right, I can go do the same thing again. I can go write the formula again, select the same thing again. Another thing I can do is I can just go in here, I can right click, I can hit copy, I can go here, I can hit paste, And what that does is it actually copies the formula from this cell to this cell. Okay, let me do that again. Let me, in fact, delete this one. What I'm trying to do here, in fact, is copy the exact same formula from here to here. But note, this is like what Iggy was doing earlier when he copied his code, right? He had to go in and kind of change set red to set green or set red to set blue as he copied the code from one line to the other. So I'm going to go in here, I'm going to copy, and I'm going to paste. But notice something really interesting. If I go back here and I go here, it says, hey, count column B and look for M3. Look for the criteria M3. M3, which happens to be the secret identity. But if I go here, right, I found that, oh, wow, it already updated it to M4. Somehow it knew that when I copied the formula from the line above to the line below, that it should advance this cell to the next line. Pretty cool, huh? So spreadsheets do some interesting stuff where it's its own way of operating. These functions are a little different. They're used for data manipulation. And they start doing interesting things like as we copy paste them, it's almost like they know our mind. See, if I copy it now, it's M5. If I copy it now, it's M6. Very interesting, right? But now imagine, let's change the problem a little bit, okay? Change the problem a little bit. Remember, there were only 4 types of secret identities. Okay. Oh, by the way, before I do that, let's answer the question, which was, hey, what was the question? The question was, how many appearances of comic book characters have there been in total? So we answered that when we did, and this one is which ID has the most number of appearances? So we first identified, or we first extracted the number of IDs by using the unique function. Then we went and we added, or we counted the number of secret identities in that column, only if it was secret identity, only if it was public, only if it was no dual, and only if it was known to author. And from here, we can clearly see that secret identity is the maximum number of characters in this particular data set. Okay, I'm going to do one more, and then I think, in fact, what I'll do is I won't give you homework tonight. I'll do one more. Tomorrow night, we'll come back. We'll do a few more of these. We'll talk about artificial intelligence tomorrow. And then you guys can try this stuff over the weekend because we love you so much. Okay, so let's do the next one. Or let's do a similar one where I told you can copy, paste these formulae or these functions from one cell to the other. Well, that's kind of fun, right? That's okay. But now, again, I can only copy it because there's only 4 of these here. It's easy to copy it 4 times, right? What if I had like 50 of them and I had to copy them? So let's look at what that looks like to us, okay? So we'll go in here, we'll delete this data, and we'll come back here and say, hey, how many types of eyes are there? Okay, so we'll go equals unique. If I can type. And then we go to the eye column, D. We ask ourselves, how many types of eyes are there? Oh, wow, look at that. There's so many types of eyes, okay? And now I'm going to go, right, number of eye people. How many number of people have those eyes? Number of people with those eyes, right? And so I'm going to go equals count ifs. And then I'm going to go, hey, count that eyes column and tell me how many people have hazel eyes. Boom. Life is good. 76 people have hazel eyes. If I copy this, I get, 1,962 people have blue eyes, 1924 have brown eyes. But think about this now. Am I going to go copy, paste, copy, paste, copy, paste for each of these things? Oh my gosh, so annoying. Copy, paste, copy, paste, copy, paste, copy, paste. Instead, I can do this. Check this out. This is real magic, real magic. Watch carefully, okay? So I'm going to go here. I'm going to click this thing here, and I'm just going to pull this down. And now what happened was this got copied to the entire set of data, right? So there are 0 people with blank eyes. Thank God. And then as you go through this, you find that, hey, now I can do a total of how many people are there with however many eyes there were. Now I can do another thing as well. Sorry. Another way to do this is just triple click this column. Instead of dragging it down, I can go to this dot and just go 1, 2, 3 clicks. And the third click, Sheets knows to spread that formula out over as many lines of data it has right next to it. Okay, so it's getting a little late. We're going to stop today and come back tomorrow. A couple of things to revise. Spreadsheets, we got that. Columns, rows, we got that. Special functions, right? The ideas of for loops, if statements and such are all very much alive and well here. But when you're manipulating data, it's really hard to write JavaScript and to do that. You can do it, but it's kind of like you have so many different things you may want to do. So instead, we're learning some new types of functions in a tool called Google Sheets. And there's also other stuff like Excel, which you could use. And what we learned today was two things. One is the unique function, which kind of extracts the how many unique pieces of data exist in a column. And the second thing we've learned is count ifs, which is, hey, count based on a set of criteria. The third thing we learned, which we learned that second, which was sum, right, which is an example of a function which can be applied to a single cell or a range of cells, and it just ends up adding a whole bunch of stuff to it. Okay, so with that, I think we will end for today. We'll come back tomorrow. We'll do some more complicated data manipulation stuff, and then we'll go into artificial intelligence tomorrow. Sound good? Everyone, feel free to look at the rest of the slides if you want tonight and play around. If you feel challenged, you can try some of the exercises. They are on slide 14. There's a whole bunch of stuff. I intend to go through the first 3 tomorrow, or maybe the first 2 tomorrow. Yeah, first 3 tomorrow. And then we'll leave these for you guys to try on the weekend. Okay? All right. Thank you, everyone. Have a good night. And we shall see you guys tomorrow. Take care. Bye. Thanks, Alex.